Hello all, welcome back to Data Science Brain. In this video, we will be doing another fun project where we will be making an end-to-end machine learning application for stock prediction. So, this is how our application will be working. So, we'll be selecting these options like gender, male, and then we'll be entering the age. We'll say hypertension, we have heart disease, and our work type is, let's say, self-employed, and marital status is yes, residence type urban, glucose level, let us say it's around 500, BMI, let's say it's around 60, and smoking status smokes. And once we click predict stroke, see it was predicted that we'll be having a chance to get stroke. Okay, so predicted stroke 1 means there's a chance to get stroke. So similarly, let us enter the lower values like gender is female. Females tend to have a less chance of getting stroke. Age 20, heart disease no, hypertension no, ever married no, work type never worked, glucose level let's say 80, residence type rural, and BMI let's say 30, smokes never smoked. And as you can see, it has predicted stroke to be 0. That means this guy doesn't have a chance to get stroke. So that's what we will be building, a web application for stroke prediction. Okay, so first of all, we will be actually doing an exploratory data analysis on the stroke dataset. So we will be actually making this project based on this dataset, like stroke prediction Kaggle. So there's this dataset for stroke prediction from Kaggle. So this is the dataset that we'll be using. And so first of all, we'll be doing some exploratory data analysis. And after that, we'll be proceeding with this application. Okay. So let's get started with the code. Kindly leave a like and kindly comment your suggestions in the comment box, and also subscribe to my YouTube channel if you haven't already. Okay. So I have made numerous tutorials and projects like this. You can check it out in the playlist. So kindly leave a like, share this video with your friends, and leave a comment. Okay, let's start by importing the dataset. Okay, so as we have done in all our previous projects, we will be mounting the Google Drive. Okay, so let's click on Mount Drive. So this will basically allow us to import the dataset after uploading it to Google Drive. Okay, so I have already uploaded mine. So I'll be mounting the Google Drive now, and I will just copy the path here, and I will keep it. Okay, so as usual, we will use pandas. So import pandas as PD, not DP, PD. Shift enter, and it will run the code, and we will store it into a data frame. Okay, so let's say df is equal to pd dot read csv. We will use the read csv function from pandas to read the dataset. So I will paste the path that I have just copied. So this will load the dataset, and let's just take a quick look at the dataset. Let's say head, shift enter, and we can see the dataset here. And also we can see that this id column here, which is not really useful for us, so we can just drop that. So we will say df is equal to df dot drop, and we will say we need to drop id from which axis, from the first axis. Okay, so it will drop the column. Okay, I typed in prop. Okay, so it will drop id from the columns. Okay, and we will again say not there, we will just copy and paste here. So we'll do the drop, and then we will just look at the dataset. Okay, so as you can see, these are the columns we have. So these are all the feature columns, and this is the this is the column that we are trying to predict. Okay, so stroke is our target column. Okay, so we will just print it like this. Okay, we don't have to use head. So we can see both head and tail here. So we can see stroke has like binary values 1 and 0. And let us take a look at other features: gender, age, hypertension, heart disease, ever married, work type, residence type, glucose level, BMI, and smoking status. So these are all our features. These features will decide this target. Okay, so gender, male or female, So we'll be further looking at all of these features individually and seeing how these will affect the our target variable. So just a quick look: gender, male and female, age is there, hypertension is also looking like a binary value, heart disease is also binary value, ever married is also a categorical variable. It will be having two values. Gender is also categorical, and work type is also, I believe, having categorical values, like few of the repeated values. Residence type is also same. Glucose level is a numerical value, continuous numerical value. BMI is also a continuous numerical value, and smoking status is again a categorical variable. Okay, so that's a quick look. And gender means obviously male, female. Age is the age of the patient. I mean, age of the person. Hypertension says that, whether or not the person has hypertension or not. One means he has it. Zero means he doesn't have it. Heart disease is also same. One means the patient has heart disease. Zero means he doesn't have. Ever married also has yes or no. Yes means he's married. No means he isn't married. Okay. Uh, and also I think it is better to you know uh, write some code to see the different columns here and its different values, I think. So let us look at the unique values in all the categorical features. So we will say categorical features. Categorical features is equal to, let's make a list of all the names. I'll just copy it like this. And gender is one, age is not, hypertension. And now we will get the unique values. Okay, so it's a unique values is equal to, we'll say, for call in categorical features. uh, we will say we will map call to the unique values. Okay, the unique values in that particular column. Okay, so this will give us a object containing the column name with its unique values as an array. Okay, so we will just do this and we will print that out. In this way it is not that easy to read, so let us make it little bit more readable. So we'll say call values in unique values dot items. Now this is really useful in Google Colab. Okay, so we have this feature where we'll get suggestions to what all code that we'll be probably going to write. Okay, so as you can see, gender has male, female, and other. Hypertension, as we have discussed, has 0 and 1. 1 meaning it has hypertension, 0 meaning no hypertension. Heart disease is also similar. So 1 means has, 0 means doesn't have. Ever married, yes or no. Work type, private, self-employed, government job, children. Children here means the patient or whoever the dataset is collected from is a child. Okay, so children never worked. Okay, residence type, urban and rural. Two residence types. Smoking status, formerly smoked, never smoked, smokes, and unknown. Okay, stroke, our target variable, has only two values. So the problem at hand is a binary classification. Okay, so binary classification is the task. So I mean, you can say it's a classification or a prediction. So we are basically predicting stroke, right? So we can say it's a prediction. Okay, so that's the thing. So basically, in machine learning terms, this is a classification, isn't it? So this is a binary classification machine learning problem. But when we are like communicating this with someone, so we'll be saying like, this is our model is a stroke prediction model. Okay, our application is a stroke prediction application. So understand the difference. Okay, so this is a classification problem in terms of machine learning perspective. But in like in a like when we are trying to communicate this to someone else or general audience, we will say our application is a stroke prediction application. Okay, so it's an interchangeable thing. So now we will further explore the dataset. So we will check for some any duplicated rows here. So we'll say duplicated dot sum. So this will return us the sum of all the duplicated rows, and we can see there are no duplicated rows here. We don't have any duplicated rows. And now let us just see some information about the dataset. Okay, so we will use the common info function to see some of the information about the dataset. So we can see there are 5110 entries. That means there are 5110 rows here, and we can see most of the columns are having complete values. There are no null values, but BMI column only has 4909 non-null values. That means that there are some null values in present in BMI column, as we can also see here. We can see NaN here. So we have null values in BMI column, and we need to handle this. Okay. And as I have mentioned before, we have many categorical variables here, and which we need to deal with, because machine learning models generally tend to work well with numerical values. Okay, so we have to convert the categorical variables to numerical variables later on. Okay, and also we need to deal with the null values. So that's what we have from a quick look. And so our problem is binary classification problem, and at present we need to deal with two things: null values and categorical variables. So let us again further explore. Let us explore the dataset a bit more. So now let us take a quick look at the at our target variable. Okay, so we'll say y is equal to df stroke. Okay, so this is our target variable. So let us take a quick look at it. So we will let's say we need to see the number of values here. So we'll say value counts, and let us say okay, let us see this. Let us see the different counts for different values here. So we have two values, 0 and 1, and these are the respective counts for it. So we need to better understand its spread of these values. I mean, spread means the proportion of these values. We'll normalize it. We'll say normalize is equal to true, and let us take a look at it again. Okay, normalize. No, it's not normalize. It's normalize. Okay, so we can see this is the proportion 0.95 portion of the stroke column is for 0, and only 0.04 portion of it is having 1 as value. Okay, so there's a huge imbalance. Okay, so for seeing it better, we can just, I think, by multiplying this we will be getting. So as you can see, 95% of the data set for this stroke is 0, and only 4% is having 1 as value. Okay, so we have a highly imbalanced data set. Okay, so whenever you are trying to collect a data set for any machine learning application, try to make sure that if it's a binary classification problem, both the classes both the classes must have equal proportions, okay, in your data set. So that means whoever collected this data set should have included 50% of the dataset with people who had heart attack, stroke. Okay, so you should include 50% of the dataset with people who had stroke. That means one must be having at least close to 50% of the proportion of the dataset. Okay, so in our case we only had 5% of the dataset with class 1. Okay, rest of the 95% of the dataset is having class 0. So we have an imbalanced dataset, and we need to use some of the methods that is used commonly for handling imbalanced dataset. Okay, so because machine learning models generally, most of the machine learning models don't work that good with the imbalanced dataset. Okay, so just to visualize how big this difference is, we can just maybe create a histogram. Okay, so we will use a common library known as Plotly. So if you haven't, if you are using this code in your own machine, you might have to install this separately, Plotly. So I am importing Plotly dot express as px. Okay, so this would probably do it. And oh, I have got a suggestion. Let us just check it. What will it give? Let's see. Okay, we have got a chart suggestion by Google Colab, and it looks pretty good enough. Okay, so yeah, we can use this as well. So as you can see, the proportion of 1 versus 0 is really, the difference between the proportion of 1 and 0 is really huge here. Okay, so one thing we have to do while building this machine learning model is to use the correct metric. Okay, so we cannot use accuracy as a metrics here, because it will be misleading. Okay, so the choice of wrong metric can mean choosing the wrong algorithm as well. Okay, so we can see that the target is skewed, and the best metric for this binary classification problem will be area under the curve. Okay, I mean accuracy will not be a good metric for an imbalanced data set. Okay, because it will give us misleading result, because if it predicts uh, all the time, if it predicts zero, it will still end up having 95% correct prediction, isn't it? So imagine, it is predicting zero all the time. It will always have 95% as accuracy, because 95% of the data set is having class zero. Okay, so I mean all the model has to do to get 95% accuracy is to predict zero all the time. If it does that, it will get 95% accuracy, isn't it? So accuracy is not a good metric for using this. I mean metric to use for this machine learning model. Okay, so we'll be using a metric like ROC, or area under the curve. Okay, so area under the ROC curve. So I mean it combines the I mean goodness of precision and recall metrics. Okay, so it combines these two metrics, precision and recall, which are better metrics for this kind of imbalanced data sets than accuracy. Okay, so also we need to do some more exploration of our data set. So we have seen the numerical, I mean we have seen the categorical data sets, categorical features. So now let us see the numerical features. Okay, so age, average glucose level, and BMI, and we will describe it. So as you can see, using Google Colab for learning purpose is really good. It gives us these suggestions. Okay, so as you can see, the maximum age of the person in this data set is 82, and the maximum glucose level is 271, maximum BMI 97, and minimum age is 0, something like that. And minimum glucose level, minimum average glucose level is 55, and minimum BMI is 10. Okay, so we can also see some other things here. So we can see the difference between the mean and the median here. Okay, so let us see the mean of age is 43, and the median, so 50th percentile. So these are percentiles. Okay, so 25th percentile, 50th percentile, and 75th percentile. Okay, so 50th percentile is also called as median. Okay, so we can see the mean is less than the median. Okay, so what does that mean? So the mean is less than median means the age column is left skewed. Okay, so it is skewed to the left side. Okay, so that is what median greater than mean means. Okay, and also we can see BMI. Okay, BMI has a mean of 28, but its median is less than that, isn't it? So what does that mean? If the median is less than mean, it means it is right skewed. Okay, so it is right skewed. So also average glucose level also has a mean of 106, but the median is 91. Okay, median is less. So what does that mean? It is right skewed. Okay, it has right skew. So we can also see the skewness here. So let us say, I mean, we can see it in numbers first, and then we will actually draw something. And let us say if we get a suggestion here, we have got a suggestion. So let us go with that. So let us see it in figure itself. So as you can see, there is a right skew for glucose level. Okay, so median comes somewhere here, and the mean comes somewhere here. Okay, so median is less than the mean. So if median is less than mean, there is right skew. Okay, it is skewed to the right side, as you can see. Okay, and also age has left skew, isn't it? So that means median is greater. Median is somewhere here, and median is somewhere here, and mean is somewhere here. Okay, so mean is less than median means left skew. Mean is greater than median means right skew. Okay, BMI also has a right skew here. So we have seen that here. Okay, so that's about the skewness of these data, these features. So we need to deal with skewness as well. Okay, so we'll use some standardization like standard scaler, and also some power transformations to deal with this skewness. So because most machine learning models prefer a bell curve. Okay, so a bell shaped curve, that is what most machine learning models will prefer. So it prefers a data set that will look like this. So most machine learning models prefer the features to have a curve, that a histogram that looks like this. Okay, so a bell curve, this look like a bell, isn't it? So most machine learning models prefer feature with this kind of a curve when we draw a histogram. Okay, so that is why we need to deal with skewness. Okay, so we will use techniques like standardization and power transformation to make our features look similar to this. Okay, so that's about that. So let us take a look at the rest of the data set. Okay, so we will say we will create a figure. Let's say px dot, let's make a histogram. Let us go with the suggestion. Okay, let us just try the suggestion and see what it gives us. So we'll say gender here, and we will put the width to 400 here. Let us just see what it gives us. So as you can see, this is the proportion of the male and female here. We can see that the count for the female is more than the male in our data set. So now let us see the probability of getting a stroke based on whether or not the person is a male or female. Okay, so let us say df of df gender, and gender is equal to, first let us check for the male, male, and so if it's a male, then we need to get the we need to see the stroke. Okay, so we are basically getting all the patients who had stroke when he or she, I mean when that person is a male. Okay, so mean, let us multiply this by 100. Okay, so let us see. So as you can see, it is around 5%. Okay, so this means that a male gender in this data set has a probability of 5.1 percentage to get a stroke. Let us round it to get a better understanding. So we will round it. We need to round it here, right? So we'll round it here to 2 places. So okay, 5.11 percentage of chance to get stroke. Okay, so males have 5.11 percentage of chance to get a stroke. So let us do the same for female. So let us say female. So females has a chance of 4.71 percentage to get stroke. Okay, so that means a males, I mean males have a higher chance of getting stroke. According to this data set, we can see that males are having higher chance of getting stroke, okay, compared to females. So let us again go and explore the other features just like this. So we will say the next one, we'll just copy this, okay, for the uh, other columns as well. So we will pass in hypertension here. So we will say hypertension, and let us see. So as you can see, the proportion of hypertension we have in our data set, there are more people having not having hypertension than the people who are having hypertension. Okay, so this is the proportion of that data set. Now let us try to see the probability of getting stroke for people having hypertension. So let us say is equal to 1. Let us see. As you can see, people with hypertension has a 13 percentage chance to get stroke. Okay, so people who are having hypertension has 13.25 probability to, I mean percentage to get stroke. Okay, so let us change this to 0 and see the difference. So as you can see, person who doesn't have hypertension only has 3% chance to get stroke. Okay, so person who doesn't have hypertension has less chance of getting a stroke. So similarly, let us see the other feature as well. So next one is heart disease. Okay, so let us draw for heart disease. Okay, sorry, not here. Okay, so let us draw the diagram first to see the proportion of heart disease. Heart disease also has a similar proportion. People with heart disease is in low count in this data set than the people with. There are more people with heart disease. I mean, there are more people without heart disease in this data set than people with heart disease. So let us check whether or not people with heart disease has a chance of getting stroke. I mean, what is the probability to get stroke? So we can see there are 17 percentage chance for a person with heart disease to have stroke. Okay, so 17 percentage chance is there for a person with heart disease to have stroke. Okay, So let us check for not having heart disease. So there is only 4% chance for a person without heart disease for getting stroke. Okay. So that's about heart disease. Now let us move on. Similarly, for the other categorical features. So ever married, let us take ever married and see the proportion of the data set. As you can see, there are more people who are married than non-married. Okay, so in this data set, there are more people are married. Okay, so let us do the same thing. Let us check whether or not a married person will get heart attack more than non-married person. So let us say the person is married, and what is the percentage of? Okay, oh sorry, sorry. It is not like that. It is yes or no. It is not one or two. It's yes or no. Okay. So there is a 6% of chance for a person who is married to have heart attack. I mean stroke. Okay. Both are similar. Okay. And only 1% of chance for a person who is not married to get stroke. That means married people get stroke more often. Okay. At least according to this data set, that's what it means. Okay. So let's continue. So what's the next? The next categorical variable is work type. Okay, so let us take a look at the histogram for that. So as you can see, private work type is more here, and all the other ones have similar proportion and never worked. There is only very few people, only 22 people in this dataset have never worked. Okay, so that's interesting data. Let us do the same thing for all the people here. Let us do a loop here. Okay, let us not copy and paste this several times. Let us just do a loop here. So let us see it all together. So we'll just let it there. We'll say stroke percentages work type. Okay, it has suggested us this code. Let us just go by it. So as you can see, it is making it really easy for us. Okay, so I will suggest all of you to use this same IDE while you are learning Google Colab. Let us just print it and see. As you can see, self-employed person has more chance of getting stroke. Okay, a person who has never worked has 0% chance of getting stroke. Okay, so your secret for not getting stroke is to never work. Okay, just kidding. So self-employed people, according to this data set, self-employed people have more percentage of chance to get stroke. Okay, so that's about work type. So what is the next thing? What was the next thing? I think it's a residence type, isn't it? So next is residence type. So we'll do the same thing here. So we have two residence types. So thankfully both residence types have a proportion that is equal. Okay, so we have equal proportion of people here, both from urban and rural areas. We have equal proportion here. Okay, so let us do the same thing. Let us okay, let us just do this group by. Okay, let us do this group by. Instead of work type, we have residence type. Okay, residence type. So let us see. Okay, so according to this, people who are living in urban areas have more percentage, more chance of getting stroke. Okay, little bit more. Okay, the difference is not huge, but there is a small difference. Okay, so next is one of the interesting columns, smoking status. Okay, most people will be really worried, whether or not they will get stroke because they are smoking. So let us check that. So before that, I'm just telling you, whatever result that you are getting is totally dependent on this data set. Okay, this is not uh, this doesn't mean that people who are smoking or not smoking doesn't get stroke. Okay, so this is just a data analysis based on this data set. This doesn't prove anything or don't prove anything. Okay, so let us see the proportion that we have here is there are more people who have never smoked in this data set than people who have smoked. So let us check the same thing for this data as well, smoking status. So we'll just replace this with smoking status and see. Okay, so as you can see, people who have formerly smoked has more chance of getting stroke than people who have never smoked. Okay, but as you can see, the percentage difference is very few. Okay, the difference is not that big, but still, you know, if the data is to be trusted, then obviously people who are smoking has a higher chance of getting stroke. Okay, I mean, the percentage, if you are into data analysis and if you know statistics, then you know that, you know, this is a really small percentage considering the fact that, you know, our data set only has this many number of rows. Okay, so let us continue. So the next one is, so we have seen all the categorical variables and their I mean the percentage of chance of getting stroke because of different values in those categorical variables. So now let us understand the actual dependency of these categorical variables with our target variable. Okay, so the degree of dependency between this categorical variables and the target variable. Okay, and we can measure it using a using something called as mutual info score. Okay, so we can import from from sklearn from sklearn dot metrics. Let us import mutual. Let's see if I get a suggestion. Yes, mutual info score. Okay, so we can use this to get the dependency, the degree of dependency between the categorical variables and our target variable. Okay, so higher value of mutual information mean higher degree of dependency. Okay, and higher like, you know, higher mutual info score implies that, you know, we can get a better prediction on the target variable if we use that particular categorical variable. Okay, so let us check that. Let us check the info score for all the variables. So let us again make the list of all the categorical variables. I guess we had this made before. Anyway, so let us continue. And then we got a suggestion here. Let us try it out maybe. Yeah, let us try it out. This is perfect. So it is basically taking all the columns from this list, and it is checking the mutual info score for each with this stroke variable. Okay, and it is printing. So this is perfect. Let us go on with it. Okay, but it is not really printing it pretty well. So we need to actually do something like dot to f. I think this will do. Okay, so as you can see, we have here the mutual info scores for all these variables, as you can see. So the actually the dependency for our categorical variables with our predicted with our target variable is really low. Okay, so as per this mutual scores, we can see that, you know, the dependency between our categorical variables and our target variable is really low. Okay, only some of these features like, you know, heart disease, hypertension, and work type has a really small dependency. I mean, our stock target variable has a really small dependency with hypertension, heart disease, ever married, and work type. Okay, so it is not really significant. Okay, we don't have a high like, you know, dependency uh, between these categorical variables and target variables. Okay, so our categorical variables has almost no effect on the target variable. Okay, so let us do a similar kind of like dependency visualization. I mean, let us see the dependency for also our numerical features. Okay, so we will see the correlation metrics here. So as you can see, uh, we can see the correlation between these variables. Okay, so we actually forgot the target variable. Okay, so we need to, that's what we need to see. We need to see the correlation between these numerical variables and our target variable. Okay, so let us say plus stroke. I think this will work. So as you can see, um, so, you know, you can see there's a really, I mean, there's a slight, or there's a small positive correlation between age and stroke, which is obvious actually. As age increases, your chance of getting stroke obviously increases. And also we can see average glucose level also has a really small positive correlation between stroke. Okay, obviously as glucose level increases, your chance of getting stroke also increases. BMI doesn't, according to this data set, BMI doesn't really actually have you know, a direct correlation between it is nearly zero. Okay, so it doesn't have an inverse, or it doesn't have a positive or negative correlation with stroke. Okay, It's near zero. Okay, so age does have a small correlation with stroke. Okay, so actually we are done with our data analysis part. Okay, so what have we learned? We have learned that people, I mean as age increases, stroke increases. I mean chance of getting stroke increases. Also average glucose level has a really slight chance of causing stroke. BMI doesn't have any much effect on stroke. And as we move to the top, we can see the categorical variables doesn't really have much influence on the on whether or not you are going to get stroke or not, as per this mutual info score. But when we move up, we can see that person who have formerly smoked has a slightly more chance of getting stroke than person who have not smoked. Similarly, person who are living in urban area, this difference is really insignificant. Okay, so let us not talk about that. And as you can see, self-employed person has a slightly more chance of getting stroke than other kind of other work types. Also, a person who is married has a slightly higher chance of getting stroke than a non-married person. And also we also saw that person who had heart disease had a higher chance of getting stroke than a person who didn't had heart disease. Same with hypertension. Okay, and also as big, I mean in terms of gender, a male had a higher chance of getting stroke than female. Okay, I mean it is also really insignificant. Okay, so that's all about our data analysis part. Also we know that we have some skewness to deal with, also some null values to deal with. Here we have some null values to deal with, and we also have in our target variable we have an imbalanced data set. Okay, so we need to deal with all of these things. So next step is dealing with that. Okay, making the machine learning model uh, you know while dealing with all these things. Okay, so I have just written down these things here that I have just mentioned about the features. So let us start by dividing the getting the column separately, the numerical and categorical variables. As we have mentioned, we need to do some transformations, right? So we need to deal with null values, skewness, and also we need to apply some methods to deal with imbalanced data set as well. And also for the categorical variables, we need to convert them to we need to convert them to numerical ones. Okay, basically we need to encode it. So we have some categorical variables here, we need to encode them as well. Okay, and also one more thing, as you can see, uh, the numerical values have different scales, isn't it? So this okay, where was the description, I mean details. Okay, so BMI ranges from 10 to 97, and average glucose level ranges from 55 to 271. Okay, also age ranges from 22 to 82. So these things have different ranges, so we need to make it into we need to we need to standardize it. Okay, so basically we need to scale it to a similar scale. Okay, we need to make it to a similar scale alongside dealing with the skewness. Okay, so those are the things that we need to do: scaling, power transformation to deal with skewness, and imputer, simple imputer for dealing with null values. Okay, so basically replacing the null values with some strategy like mean or median. Also one hot encoder, we'll be using one hot encoder for encoding the categorical variables. Okay, so those are the things. So let's say let's divide the numerical variables and categorical. Numerical is equal to, so these are the numerical variables, and for categorical we have these. And so I will be using pipeline. So pipeline is something that will allow us to do transformations on all these data sets, multiple transformations on our data. Okay, so that's what pipeline is used for. So from, also I have libraries that we will be using. I will explain each one of these as and when we use them. Okay, so let us now apply these transformations that we have mentioned. So BMI has null values, right? So we need to deal with that. So the method that we will be using to deal with null values is called simple imputer. Okay, so simple imputer and takes a strategy and it will replace the null values with that strategy. Okay, so let us create a let us use something called as a column transformer. I will explain it. Let me just type it in. Okay, so a column transformer is something that takes in a column or a set of columns and apply some transformations. Okay, so that's what a column transformer does. So it takes in transformers, which is an array of tuples. Okay, so we have an array of tuples, and inside that tuples we will mention like this. Okay, so we will mention a name for our transformer and what transformations to do and on which columns. Okay, so name, the transformation, okay, name, transformation, and on which columns the transformation should be done. So these are the three values that we need to pass in as a tuple to this transformers array. Okay, so the column transformer will apply the transformations on particular columns. Okay, so that's what column transformer is used for. So we have more transformations here, not just power transformer. We need imputer to convert the null values, and then we need the power transformer, right? So we have two transformations here. So for that, as I have mentioned before, we will be using pipeline. So pipeline lets us to do multiple transformations in a single, like we can put together multiple transformations for a column. Okay, so using pipeline. So inside pipeline, the first transformation is imputer, right? So first of all, we need to impute it. So as I have mentioned, we will be using simple imputer, and simple imputer will basically take in any null values and replace it with a strategy. So we will type in here strategy, and the strategy that we will be using is median. So what happens here is that the simple imputer will convert all the null values in any of these columns that is mentioned in this numerical array. Basically we have null values in BMI, so it will replace the null values in BMI column with the median of all the values in BMI column. Okay, so that is our strategy here. So imputer is the name of the transformer, simple imputer is the strategy. Okay, simple imputer is what we will be doing. So that's the first tuple. So yeah, where should I put the comma? Okay, so the next transformation in this pipeline is power transformer, right? So we need to do power transformer. So why are we doing this? We are doing this to turn this skewness. Okay, so we are doing this to deal with this skewness. So skew dataset might not perform as good as a normal distribution. Okay, a normal distribution is also called as Gaussian distribution. So a power transformer will allow us to convert skewed datasets into normal distributions. Okay, which are much better for machine learning models to deal with. So I'll show you again what normal distribution is, as I have mentioned before. So as you can see, so this is a normal distribution. Okay, as you can see, this is a normal distribution, and machine learning models tend to do better on normal distribution. The blue one is normal distribution, the other two are skewed. The green one is right skewed and the red one is left skewed. Okay, and machine learning models does better on normal distribution datasets. So that's why we are doing power transformations here. So we will also do one more thing. We will say standardize is equal to true. So after power transformation, we will also standardize it. So that's also something that I have mentioned before. Why do we do it? Because our numerical values have different ranges, isn't it? So the range for an age will be between 0 to 100 or something like that. But that is not the same range for a variable like BMI or average glucose level, right? Average glucose level will be having a much higher range of values, isn't it? So the range is different, and in that case, what happens is that I will show you what will happen. So as we can, let's take a look at the dataset. So in the case where different features have different scales, what the machine learning model will do is that it will give more importance to the feature that has a higher value. Okay, so some models, okay, not all models, some models tend to give more importance to the columns having higher values. Okay, so it can go both ways. So differences in scale will mean that the model will treat these different features differently. Okay, but we don't need that, right? I mean, we don't need that to happen on its own. I mean, obviously we can tell the model to give little bit more importance to one of these columns, but that control should be on us, isn't it? So we have to control those things, right? So if you don't scale all the features to a equal scale, what happens is that the model will automatically assign importance to importance differently to different columns. Okay, so that control should be uh, within our hands, right? So we should be the one who is telling the model which features will be having higher priority. The model should not be deciding on that based on the values. So that's the reason why we are going to make all the features, all the numerical features in the same range. Okay, so that's why standardize is equal to true is given here. So after power transformation, after making it to normal distribution, it will standardize it. Okay, so those are the transformations that we need to do on the numerical columns. These three columns we will we will use simple imputer to replace the null values with the median value, then power transformer with standardization. Okay, and next is categorical variable, isn't it? So next is our categorical variable, and we only need to do one thing, encode it. So this categorical variables that we have here will be encoded to numerical values, like I have explained before. Column ever married will be converted to two columns. Okay, ever married yes and ever married no, and in whichever rows ever married has an yes, it will be the ever married yes column will be having one, and wherever it is no, the ever married yes column will be having 0 there. Okay, so this will basically convert this binary digit column to two columns. Okay, so if the column has more than two values, or if there are five values, it will be converted to five different columns. Okay, so that is how usually imputer one hot encoders works. I believe one hot encoder also. So just to make sure that let us just search for it, one hot encoder working. So as we have mentioned, it's the same thing. It will be creating a new binary columns for each unique category in the data, just like how I have mentioned. Okay, so yeah, so that's what one hot encoder will does. So those are the two transformations that we will be doing. So let us just see if there are any further transformations needed. uh, okay, so those are the two column transformations. Okay, so after that, one more thing we need to do, one more issue we had. What was that? We have imbalanced data set, isn't it? So we need to deal with that as well. So that imbalance, the method that we'll be using to deal with imbalanced data set should be applied to the whole data set. Okay, so for that we'll be using pipeline again. Pipeline is something that is used to uh, give transformations to the whole data set. Okay, so multiple transformations. Okay, so in the pipeline, these are the steps. So I have received the correct suggestion actually. So first of all, we will be using this transformer that we have made, and that will be the first step. So our dataset will go through this transformer and do all these transformations, and after that we are using SMOT. So I will explain what SMOT is. So SMOT is the algorithm that we will be using for dealing with imbalanced dataset. Okay, so this will basically do one thing. Okay, so it will basically balance the dataset by either increasing the number of the minority class. So in our case, minority class is what? The people with stroke, isn't it? So the people without stroke is the majority class, 0 is the majority, and 1 is the minority, isn't it? So because of that, what SMOT does is that it will balance out this. Okay, so it will either increase the number of minority class, or decrease the number of majority class to make these two values equal, at least similar. Okay, the number of values similar. Okay, the proportion similar. So that's what SMOT does. It will balance out the target variable, so that we will be having equal number of people with stroke and without stroke in the dataset. So that's what SMOT does. SMOT is the algorithm that is used for that. Also, the full form of SMOT is synthetic minority oversampling technique. Okay, so basically synthetic means it will be creating synthetic data, not the original. It won't be duplicating the original existing data. It will create synthetic data. Okay, new data for minority class. Okay, so it will create more data for the minority class and oversampling technique. Okay, so it is a technique that is used for increasing the number of minority data. Okay, basically balancing out minority and majority classes. Okay, so that actually kind of completes our pipeline. Okay, so our pipeline for our machine learning model. So now is the time to select the machine learning model. So we'll be using a common machine learning model, one of the common machine learning models, and also or maybe few of common machine learning models, and also one like I won't call it advanced, but one ensemble model. Okay, so one normal machine learning model and one ensemble model. Ensemble is nothing but collection of models. Okay, so it's a collection of models. So we'll be using ensemble model like random forest. Okay, so we'll use random forest, and also we'll use what, something like maybe linear discriminant analysis, or maybe something like logistic regression. Okay, so let us first import those three models. Okay, so we will import. Let us do it in the next tab. Okay, so we will say random forest classifier, then we will say scale and dot not discriminant. I'm waiting for the suggestion actually. Okay, it's not suggesting me anything, so I'll just copy and paste. So we have imported the three models that we have decided to use. Okay, so random forest classifier, linear discriminant analysis, and also logistic regression. Okay, so these two are some of the base models, and this one is random forest classifier is an ensemble model. Okay, so these are the three models that we'll be using. So we'll write a function that will return us these models. Okay, in list with names. So we'll say def get models, and we'll say models comma names is equal to, we'll create two lists, list, and we'll say models dot append logistic regression. So I have imported all the models here. I have written the function for returning all the models with its names here. So now what we will do is, now we will create like the x and the y values, basically the target value and um, the values that we are using for training. So the target will be what, the column stroke, and x that represents the training data will be all the column except the column stroke, except the stroke column. So x will have all the column except stroke column. Okay, so that will be x and y, and we will also write a function for evaluating the model. So we'll say evaluate model. So we'll take in x, y, and the model for evaluation, and we will say cross validation is equal to repeated stratified k-fold cross validation. I will explain this in a bit. And then we need scores. So we'll take scores from crossval score. We'll pass in the model xy, and the scoring is not accuracy. We'll be using as we have discussed ROC AUC. Okay, so that will be the scoring that we'll be using. And I have also mentioned why we are using ROC AUC, because the area under the curve will give us a better measure than accuracy. Okay, because for imbalanced data set, that is how that is what does better. Okay, so that's why we are using area under the curve. Okay, so so that's the function that will return us the score. Now I will explain all of this. So as mentioned before, repeated stratified cross validation is a cross validation technique that is used for evaluating the performance of the model. Okay, so here n split is equal to 10 means that it is a 10-fold cross validation. So here k is equal to 10, and in a 10-fold cross validation, the dataset is split into 10 parts. Okay, 10 parts or folds. So the model is trained on 9 of these folds and tested on the remaining 1 fold at a time. Okay, so that's what it does, and this process is repeated 10 times. Okay, so each time 9 of the folds will be used for training, and the remaining one is used for testing. Okay, so n, and also n repeats is equal to 3 means we will be repeating this tenfold cross validation process 3 times. Okay, so it will be 10 into 3 30. So, okay, so 30 uh, training and testing will be done. Okay, so after completing one round of tenfold cross validation, the data is shuffled, reshuffled, and the process is repeated 2 more times. Okay, so this ensures a more robust evaluation. Okay, so that's it reduces the variance of the evaluation metrics. So that's what that is. And random state is equal to 42. I have just given right now so that we will both be getting the similar kind of results. Okay. So that's what that is. And this cross val score will be used for the cyclone function that is used for evaluating the model using the specified metrics, that is ROC AUC curve. Okay. So area under the curve. Okay, so it's like ROC means receiver operating characteristics curve. Okay, so it is a widely used binary classification evaluation metric. Okay, so it tells us how well the model separates the two classes. Okay, stroke versus non-stroke. So that is why it is much better than accuracy. Okay, so this gives a measure of how well the model separates two classes other than just accuracy. Okay, so a higher ROC AUC, a value that is closer to 1, indicate a better performance. Okay, so that is what this cross validation score will do. Okay, and this technique that we'll be using is the technique that we have mentioned here: repeated stratified k-fold cross validation. So one more thing that I haven't mentioned is stratified. Okay, so this stratified means the whenever this whenever the repeated stratified k-fold cross validation split the data set, it will ensure that each fold will be having approximately the same proportion of samples from each class as in the original data set. Okay, so this ensures that each training and testing set has a class distribution that is similar to the entire dataset. Okay, so for example, if your dataset has 1000 samples and 900 samples belong to class 0 and 100 samples belong to class 1. So in a stratified k fold, each fold will contain approximately 90% of class 0 and 10% of class 1. Okay, so it will maintain the original ratio of the classes. So that's why stratified k fold cross validation is used. Okay, so that is what our evaluation function will look like. Okay, so now let us get into training these models and evaluating. So what we will do is, actually we should move this into maybe the next line, I think, so that we can just run this. And we have x and y here. So we'll get the models and the names. Models names is equal to get models, and we'll just mention we'll just create a list for storing the results of our evaluation. Okay, actually we made a slight mistake, so we need to first apply this pipeline. Okay, so we have just created the pipeline, but we haven't used it on our dataset. So we need to use that first after creating the pipeline, and only then we can loop through the models and apply our models through it. Okay, so let us do one thing. Let us or maybe we can do this. Okay, we can just cut that from there. We will rerun this whole thing. Okay, so that we won't make the mistake. So we can put this inside the loop. Okay, so we can just pass it inside the loop, and we will add one more step here. Okay, so inside the steps we will add one more tuple, and this time what will be that? It will be our model. Okay, so that is one thing that we can do. And inside this we'll take models of I. Okay, so this will basically apply these transformations, use SMOT and pass in our dataset for evaluation to our models. Okay, not evaluation, for training to our models. So that is what this pipeline will do. So instead of models here, we will pass in our pipeline here. Okay, so that's what we will be doing. And we also need to print this, right? So we need to print this results. So how can we do that? So we'll say print I have just received a suggestion. This is really good. Okay, so this suggestions are really doing great. Okay, I think I need. What do I need? There is some error. Okay, maybe nb dot mean, right? Nb dot standard. Okay, okay. I think that will do that. We need to import numpy. I think import numpy as nb. Okay, so that will remove that error, I believe, isn't it? Okay, so that's gone. So this will print the scores uh, for us. Actually, I have a better one here. Okay, so this will print it better alongside with the names. Okay, so that's that. So let us, I think this is enough. We can just run it and we can get the results, I believe. We need to run the whole thing again. If we have made any mistakes, this will ensure that the steps will be applied correctly. Okay, so nothing, we have just we are getting all the models alongside with its name from the function we have written here. We'll be using three models: logistic regression, linear discriminant analysis, and random forest classifier. Okay, with an estimator 100. So n estimators means each estimator is a model. So random forest classifier in default uses decision trees as its estimator. Okay, so decision tree is a machine learning model. So it will be using 100 decision trees and it will average out the result and it will return us. Okay, so that's what random forest classifier will do. Basically it's a forest of trees. Okay, so that's all it is. So basically we are looping through these models and we are taking each models and we are creating a pipeline, and inside that pipeline we will be doing the transformation. We'll be using smot for dealing with imbalanced data set, and also after all that the data will be passed through the model and we'll be getting the results. Okay, so this full pipeline is passed into this evaluation, our evaluation function that we have written. Okay, so I guess this will be working well. So let us see if it works. So we'll just run it all. Okay, so actually we received an error here. So it says all intermediate steps should be transformers and implement fit transform. Okay, so the problem is our SMOT algorithm is imported from this library IMBLAN. Okay, so that is something that I have done without thinking about the pipeline. So our sklearn, our scikit-learn pipeline actually expects all the transformers to be all the intermediate steps to be transformers. Okay, so that implements fit and transform. But the smot from imbalance learn library is not a transformer. Okay, so that's why we are getting this error. So instead of that, we actually need to do something else. We either need to do is use a pipeline from the same library. We need to use a pipeline from imb learn, or we need to use smot from some other library. So let's see we can do. So let us do one thing. Let us import the pipeline from the same library. Okay, so we will import pipeline from imblearn itself. So imblearn is nothing but an extension for scikit-learn. Okay, so imblearn.pipeline, we will import pipeline. So this should work better now. Let us see. We'll run all of it again. No, it's not working well. Okay, so power transformer right now. Okay. Okay, so the problem is that column transformer, I mean pipeline cannot be imbalance pipeline cannot be used inside column transformer. Okay, so it should be scikit-learn pipeline here. But for the next pipeline, the overall pipeline, we can use what imbalance pipeline. Okay, so here we can actually use imbalance pipeline. So it will be imb learn pipeline. Okay, so we'll say imb pipeline. Okay, so this should solve the issue. Let us see. Okay, have another issue. Great. You cannot import name IMB. Oh, sorry. Okay. Should be, we cannot do like this. Okay. Let us run it and see. Ah, okay. Basically, we are missing a parenthesis somewhere. Okay, so this should be like I have mentioned, it should be a tuple. Okay, so here I should mention like power, comma, the transformation. Yeah, so that's how it should be like. Just run all again. See, these mistakes will happen. Okay, so whenever you're doing something from scratch, there will be, it is bound to have mistakes. Okay, so we have successfully run it and we have received the ROC scores for our linear regression, I mean logistic regression and linear discriminant analysis. Okay, so we can see one has 0.83, one has 0.837. So LDA did actually better than logistic regression. Let us wait for the random forest scores. Okay, so actually, the random forest did worse than LDA and logistic regression. Okay, so this could be used to due to many things. Actually, we haven't explored all the hyperparameters of random forest. We just mentioned n estimators to be 100. So we can actually like actually change some of these parameters, add more parameters, and try out. Actually, random forest classifiers work better when using grid search or randomized search CV algorithms. Okay, basically trying out different hyperparameters is the way to use random forest classifier. Okay, so in cases like these, LDA and logistic regression tend to do better job. So from this, I have decided to pick LDA as our algorithm moving forward for building the application. Okay, so our goal is to make an end-to-end machine learning project for stock prediction, isn't it? So we have done the exploratory data analysis, and we have identified the steps for building a pipeline, and also training multiple models and checking the scores, isn't it? We learned how to deal with imbalanced dataset using SMOT algorithm. So we have learned quite a lot. Now let us quickly go through the steps for building the application. Okay, so we'll be using React for the front end, and also we'll be using a simple React project for front end, and we'll be using Flask for making our API, our backend. Okay, so let us go to VS Code, Visual Code, Visual Studio Code, and for making the application. Okay, so now we will be creating the application. Okay, so for that, let us open the terminal, and here, okay, I will choose CMD. Okay, so we will say mkdir flask react app. Okay, so as I have mentioned at the start of this tutorial, that we will be making the front end for our application in React and the backend in Flask. Okay, and also I would like to mention that I won't be going in too much detail about the front end, because our goal is here to understand how to make a full stack end-to-end machine learning web application. Okay, not just a React application. So first of all, make a directory named Flask React app, and inside that we will do one thing. We will open this in terminal, and here we actually need to enable an environment. Okay, so I have already created a Python environment using Anaconda. So if you haven't already, you can watch any tutorial online on how to create a Python environment using, or a Conda environment. Okay, Anaconda environment. So we have to switch to this environment first. So I have opened the application, opened the folder in VS Code, and now the folder is empty. So let us actually create our backend file here, or let us create another folder, backend. Okay, so file, let's create another folder. Let's say backend, and inside this, let us create a file named app.py. Okay, and here we can choose the interpreter. So I will be choosing an interpreter that has, I mean, an environment that I have already made using Anaconda. Okay, so this environment has a Python interpreter. So that is the interpreter that I will be using. Okay, that is the Python interpreter that I will be using, and it is 3.12.4. Okay, so you can choose any Python interpreter here. It will be better to use the one in your Conda environment. Okay, as I have mentioned before, you have to make an environment before proceeding, because we will be going to install all the necessary libraries in that environment. Okay, so that is better instead of installing it globally. Okay. Okay, so in my case, I have already installed all the necessary libraries. So if you haven't installed, then go to Anaconda PowerShell prompt, and here you can actually say conda activates. First create your environment. Okay, so you have to first create your environment, conda create environment, and then you can activate it by saying conda activate environment. And in here you can install, you can either use conda install or pip install. I would suggest using conda install inside conda environment. If you're using pip install, try to create a normal Python environment. Okay, like Python 3 m vnv. Okay, virtual environment. And you have to install libraries like Flask. Probably you have to install scikit-learn. Scikit-learn. Then you will be have to install pandas. And imb learn. So these are the libraries that imb learn. So these are the libraries that you would have to install for making this application. Okay, so first of all, activate your environment and install these packages. Okay, and choose the same environment, same environments interpreter in the VS Code. Okay, so those are the things that you have to do. So before creating the API, we have to do one thing. So before that, API is something that will connect the front end with the back end. Okay, so it is what connect what the user sees with the actual functionality. Okay, so the backend, the app.py will be the one getting the data set, getting the data information from the front end, from the user, and running the machine learning model. All those happens in this app.py. Okay, so before that, one important step, we have made the machine learning model, we have trained it, but we haven't we haven't saved the model, right? So we'll just create another file called training.py, and in here we will put the same code that we have used from the in the collab, and we will copy and paste some of those codes, and we will instead this time we will save the model. Okay, so I have imported joblib. So this is a library that we'll be using for saving the model. Okay, so yeah, the code we have already explained, we have already seen the code. It's the same code that we have used for training the model. Only one change here is that instead of 3 models, we are using the final model that we have agreed on, the linear discriminant analysis. So we will be choosing the LDA model here. Okay, so we don't have to print anything here. So this is the model that we have agreed on, the final model that we will be using. So we will use that model, and here you can see we have called this dump method from joblib, and inside this we will be saving the machine learning model uh, as name stock prediction model. Okay, so this is how we will be saving our machine learning model. Okay, so after running this, our model will be trained on the dataset, and it will be saved here. Okay, so another one important step that we have missed is actually getting the stock dataset. So probably have to change the path as well. Okay, so we will get the path from here, and in here uh, yeah, let me just see if it's still there. Yeah, okay, so we will run this. We will call python and then training.py. Okay, okay, say python. Okay, we are getting some errors. Okay, of course, I need to cd into the folder backend, and then we will run this. Okay, so this will actually train the model, and it will save the model in the same folder. So it is basically training now, and soon enough. Okay, I think it has finished training. So you can see it has saved our model here, stock prediction model dot joblib. Okay, so we'll be using this model in our backend code. Okay, so let us write the code for the backend. So we'll say from Flask. So we are using Flask for making the APIs. Import Flask. We will also import request and JSONify, and we also might need pandas, I think, just for converting to data frame. Import pandas as PD. Also from joblib import load from Flask course import course. So course is necessary because course is something that will allow us to actually access things that are not in our own network. Okay, so course full form is cross origin resource sharing. Okay, so it will allow us to share resources from coming from different origins. Okay, this will come in handy when we are trying to connect the backend with the front end. Okay, so the backend and the front end sits on two different servers. I mean, if it sits on two different servers, then for communicating between those two, front end and backend, we need this cross origin resource sharing enabled. Okay, in the backend. Okay, so only then the backend can receive data from coming from different server. Okay, so we'll say load the trained model. So if you wonder why I am getting suggestions like this, then I am using something called tab9 AI. Okay, so this is an extension that I am using, so you can also install this extension. It will be pretty handy. Okay, you can go to extensions and install tab9 AI. Okay, so load the trained model, and here we will say model is equal to, we will get the load function, and from here we will load the machine learning model. Now we will initialize the Flask app. Okay, initialize the Flask app, and here we will say app is equal to Flask name, and as I have mentioned, we need to enable course. Okay, cross origin resource sharing. Okay, so this will enable course. So we have initialized the Flask application. Now let us write the APIs. So as I'm getting these suggestions, beautiful suggestions because of tab9 AI. Okay, so we have created a route called predict, and the method is post. So the user will be, if the method here is post, that means that this API will expect some input from the front end. Okay, so post means someone is posting something from the front end and we are getting it here. Okay, so this predict API will get data, get data that is posted from the front end. Okay, so if it's get here, then the user is asking for some data. If it's post here, then the user is sending some data. Okay, so that is the difference between get and post. So def predict, here we will say try, we'll get the data is equal to json, request dot json. So the data will be coming as a json format. Okay, from the front end as json format. So we're getting some error here. Okay, we need an except here. Every try should have an except. Okay, exception C. So we'll just return JSONify error. Let's say 500. Okay, so request.json, we'll get the data from this, and this data needs to be converted to data frame, right? So because our model uses data frame, so we need to convert this data into data frame, JSON data into data frame. So this is how we convert JSON into data frame, PT to data frame, and pass in the data as array. Okay, and we will say prediction is equal to model dot predict. We will pass in the data frame here, or let's say 0. So this model dot predict, the zeroth value will be our prediction. Okay, so we have received the prediction from here. We can just print it if you need for debugging purposes. So we'll say prediction is equal to prediction. Okay, something like this. Or let us say can do it like this as well. I prefer this. Okay. Now after receiving the prediction, after getting the prediction from our model, we will return this to the front end. Okay. So return JS. We will return it in JS1 format. So JSonify prediction, and we are JS. I mean, we are returning this object as a JSON format to the front end. Okay. And this 200 means it's a success. Okay, so we are saying we have successfully made the prediction and we are returning it, and we are sending this status. This is the status code. 200 means it's a success. 500 means it's a server error. Okay, so we are sending it back. So that's all with the API. We only have one API, predict API, for getting the data and returning the prediction. Okay, so we will also write one root API. So app dot root, and this, if someone goes to this route, they will get a welcome message, just for debugging purposes. Okay, just to see if our API is working correctly. If we go to this route, we will get this message printed. So now we will say if name is equal to main. Now we will run this. We'll write the code to run this. Okay, so we will run this in localhost. Host is equal to 0.0.0.0, and we'll mention the port. Usually backends will run in this port. Debug. Usually we put 5000 as the port to run backend locally. Okay, debug is equal to 2. Okay, so I think this will work now. So let us run this. So we'll say app.py. Okay, I think this is running. So in order to just test it, like I have mentioned, if I go to this route, we will get this message, welcome to stock prediction API. Okay, so we have successfully made our API run. Okay, so now it's time to create the front end. Okay, so just like the creating this backend, front end is also going to be very simple, but you might not be able to understand most of the code. So I have already written the code. I will just copy and paste it, and then I will try to explain some of it. Okay, so our focus is not really on the front end. Okay, because this is a purely machine learning tutorial on how to create an end-to-end machine learning application. Okay, so for this, actually you need to install Node package manager. Okay, so in order to install Node, you have to go to this Node.js website, Node.js download package manager page, and here you can do two things. So if you're using Linux, you can choose Linux here, and I will be using the LTS version. So this is long time support version, and here you can choose NVM or FNM. So I mean, I believe NVM is installed in your Linux machine. In that case, just type in this command, copy this command and paste to your terminal and run it. Okay, so since I am using Windows, I will use a pre-built installer, and I will click download here, and it will download to my Windows machine, and then I will install it from there. Okay, so kindly watch any tutorials. If you have any doubt on how to install Node.js, just comment it down. I will definitely help you out. Okay, so you have to install Node.js to move forward with installing React. Okay, so after installing Node, we will install React application here. Okay, so I have already cd'd into the out of this backend folder. Actually, I need to get into this Flask React folder. So inside this Flask React app, here is where I will be running the command to install this React app. Okay, so it is npx, type in npx, then create React app, and we will type in the app name. So this will be like, we will say front end. Okay, front end. So this will create the React application for you. Okay, so it will take some time. So it is creating, I mean, installing React DOM, and React scripts. So now, as mentioned here in the terminal, as suggestions, we will go to front end, and then we will say npm start. Okay, just to see how this looks like. So as you can see, it is getting started. So it has started the development server, and it has given us this local host where the front end application is hosted. So we will go to it and see our React application. So this is how our React application looks like now. We can see that there is this React icon here, and learn React link is here, and the text is here. Okay, so we will change all of this, and we will write our own custom code. So let us explore the code further. So we will go to front end folder, and inside this src folder, so we can see here there is some already written pre-written css here. We will just remove all those, and we can also see some of js written here. We will other than this export, we will remove all of that. We will save it. Now this will definitely crash your um, React application. And we also have some index css here. We'll just comment it for now, and this logo, we don't need this. Okay, anyway, so this is how our React application will look like. I will not go in detail about this. So basically, whatever code that we are writing that the front end user needs to see, it will be written here. Okay, in the app.js, and what all styles we are giving to our application will be written in app.css. Okay, so those are the things that you need to know. You need to know right now. So I will now just copy and paste the css that I have already written, and also the js code, and then I will explain. So I have copy and pasted the css and js. Now let us just go to the website and see our application. So as you can see, our application is running in localhost 3000 as mentioned. So I have copy and pasted all the HTML, all the JS and CSS files. Now I will explain what I am doing there. Okay, so as I have mentioned previously, I will be leaving the code to this in the description. You can get the code from there. As I have mentioned, I won't be going in detail about the front end part. Okay, so I'll explain the major part here, the important one. So that is sending the data from the front end, from our application here, from this form here to the backend, and getting the response. Okay, so that is the important part here. I'll just refresh again. So that is the important part here. So that happens here. Okay, so we are saying const response. So response is equal to await fetch. So we are waiting, and we are trying to fetch some data from the front end, from the backend, by sending some data to the backend. Okay, so we are sending some data to the backend here, and we are getting some response from the backend. Okay, so what are we sending here? We are sending data to localhost, and the port is 5000, and the API is predict. Okay, so we have created the predict API here, isn't it? So we have hosted it in port 5000, and we have created this predict API, and this predict API receives some data. It is post, so it receives some data here. Okay, so here we are receiving some data. So the user has to send some data. Okay, so what is the data here? The data is in post format, and we have added some headers here. We are basically saying that we are sending the data in JSON format, and this is the body, this is the data. Okay, so what is the data? It is form data. Okay, so what form? Which is the form? The form that contains gender, age, hypertension, all these form fields that we have, that we can see here. Okay, so the moment I fill in this value and click this predict stroke button, the form data will be collected from the front end. This form data will be collected from the front end, and it is sent as a JSON. JSON.stringify will convert this to JSON format as a JSON to the backend. Okay, to the backend, to this API. Okay, so this API will receive this data here, and it will convert to data frame here, and this data frame is passed on to model.predict here, and it will get the prediction result, and it will return back in JSON format. Okay, so once the user get this data return back in JSON format, here it is waiting for response. Okay, await response.json, it will get back this result here, and we will alert the user. We will use the alert function to just create an alert box here. That you might have seen in some websites. There is an alert box that is provided from the browser itself. So we are alerting the user by saying predict stock, this score is equal to this. Okay, so that's the major part that you have to understand here. Okay, so there is one small mistake that we have done here. So we are sending the data as prediction here, isn't it? And but we are expecting it as what, result dot stroke here. Okay, so this is the same key that we have to use here. Okay, so we have to use the stroke key here. Also, one more thing, so this will be in string format, right? So we need to convert that to integer as well. So we'll convert it to integer, and then we will send it as json dot in JSON format. Okay, so we have to run this again. We'll say control C to stop it, and we will run the backend again. Okay, so this will, oh, I think I haven't saved it. You have to stop it again and run it again. Okay, so now okay, one more thing, few more thing that I will explain. So the form that I have mentioned is created here. Okay, this is the HTML part of the JS file, of the React JS file. You don't have to worry much about it. So this is where I have built the form. Okay, you can see the gender column, gender select option here, the age input option here in the input tag, and the hypertension select box. So all these things are here. You don't have to worry much about this HTML CSS part. So if you need to learn about how to create a React application, how to write HTML CSS code, then comment it down, okay, in the comments. So if I'm going to explain all of these things in this tutorial, it is going to be more than 2-3 hours. Okay, so I have explained the important part about how we are sending the data from the front end to the back end, and how the front end is getting the data back. Okay, so that is the important part here. So if you have understood all of that, now is the time to test the application. Okay, so we have created the application. Now let us test it. Okay, so let us enter all this value. So I'm hoping for a positive stock prediction. So for that, let us enter all the maximum values here. Okay, so all the worst case values here, so that we make sure that this will receive, we will receive 1 as the result. So we'll enter all the high values here. So hopefully when I click this, after some time, we have received an alert from localhost 3000 from the backend that says, from the front end, that says predict stock 1. That means the user is likely to get stock in the future. Okay, so similarly, now let us enter all the minimum values. Okay, all the uh, very low values. Let us say a 20-year-old female with no hypertension, no heart disease, not married. Work type is, let's say he's a child. Let us change the age to, let us say, 10. Then lives in rural area, has a glucose level of just 80. Smoking status, never smoked, and BMI is, sorry, 7, something like that. Let us click the predict score, and we can say we have received 0. Okay, so our machine learning model is working successfully. It has given us, when we have entered the lowest values, it has given us stock as 0. That means the person is not likely to get stock. And when we have entered the higher values, we received stock as 1, right? So our machine learning model, our web application that uses machine learning to predict stock, is working correctly. Okay, so that's all about this tutorial. I hope you have enjoyed it. I know that I have went a bit fast in the application building part, but it is also because this tutorial is all about making an end-to-end machine learning application. The focus is on machine learning. So if you want to know how to build a front-end application like this, then kindly mention that in the comment box. I will be surely making another tutorial about it. Okay, so I hope you enjoyed this. I'll see you in the next tutorial. Until then, happy coding.